Hey scholars, I thought that a video on the 3 levels of factoring quadratics would be helpful because I realized on the quiz there is a level 3 factoring problem that if you know a trick for, it's going to make it a little easier. So here are the 3 levels that you have. You have a level 1 factoring problem where the leading coefficient is equal to 1. And that's here, right? This is the leading term. It's got the highest power of x. Nothing's written here. So there's like an automatic imaginary multiplier by 1 in front of that x squared. It's 1x squared. Level 2 is where the leading coefficient is greater than 1. So this one here, our leading coefficient is 2. And then there's also the level 3, where if you recognize this, it's going to make it a lot easier for you, where you can factor out a greatest common factor between all 3 of these terms and make the numbers a little bit smaller. So let's just start with level 1 really quick. This is a classic diamond problem where you're looking for 2 numbers that multiply to -6, but add to -1. So 2 numbers that multiply -6, I mean, usually like 3 and 2, just right off the bat, and then I know that that's going to work out, but I need them to add to -1. So I'm going to make the bigger one negative, and then double check. -3 times +2, negative times positive, I'm going to get negative, and 3 times 2 is 6, that's golden. And then -3 plus 2, or 2 minus 3, does get me back to -1. So if the leading coefficient is just 1, once you find these 2 numbers, boom, you got your answer and you're done. Perfect. All right, level 2. Level 2, we're going to do the same thing. Diamond problem. And I'm trying to find 2 numbers that multiply to 2 times 81. 161. And that is negative. And then 2 numbers that add to -9 as well. So let's see. I might need to reference my multiplication chart. 161 is kind of a big number, so I don't know what it is right off the bat. So I'm just going to be like, okay, well, I know 161 is 2 times 81. And I know that 81 is 9 times 9. Oh, so that's nice. Oh, and then the 9s are 3 and 3. So all of my prime factors are 2 times 3 times 3 times 3 times 3 gets me to 161. So some combination of these numbers multiplied together are going to be my 2 numbers. I'm going to try 9 times 18 because I have 9, and then 2 times 9 would be 18. So 9 times 18, I know that that's going to get me to 161. And I want -9. So if I add these together, then 9 plus -18 will be -9. Sweet. So then the way you can do this overshoot and dial back way. So once I have these 2 numbers, I'm just going to plug those into my parentheses, and I'm going to say x plus 9, and then x minus 18. And then I'm going to overshoot. I'm going to put that leading coefficient in there as 2. And then I'm just going to pull out things, factor out common factors between these 2 sets of parentheses. So here, 2 and 9, they don't have anything in common. I can't factor anything out. But here, 2 and 18, I could definitely pull out a 2 there. So I'm going to do that. So I'm going to pull out my 2, and then 2 times what gets me back to 2x. And then 2 times what gets me back to 18. whatever I was able to factor out is just extra. So I'm just going to get rid of that. And my answer is going to be 2x plus 9 and x minus 9. So last level, final level, level 3, is where if you notice that there's a greatest common factor between each of these terms and you pull that out first, it's really going to help you out. There can be other things where they give a common factor between all of them that's not necessarily a number. So this could have been written as, you know, like 6x squared y plus 20xy minus 16y. And you look at that and go, oh my gosh, do I know how to factor that when there's more than one variable? Well, yeah, of course you do. It doesn't matter if these are y's or if they're footballs or hearts or stars. You can still, each term has a y in it, so you can pull that out. Let me show you that with just the numbers first. So here, each one of these numbers is divisible by a factor, right? What number can I pull out of all three of those? I can factor out a 2 because each of them is divisible by 2. Let's see, can I get any higher number? I always ask myself, like, you could factor out the 2, and let's say that they had a common factor of 4, which I saw the 16 and the 20 and thought, oh, maybe it's 4. You could factor out the 2 first and then notice that they're all still divisible by 2, and then you could factor out another 2 and then you get 4. But this 6 isn't divisible by 4. None of these are divisible by 6, so I know that this is my highest factor here. So I'm just going to pull that out, and I'm just going to use bracket parentheses. You can use regular parentheses, it doesn't matter. I just want to highlight this. 2 times what gets me back to 6x squared? 2 times what gets me back to 20x? And then 2 times what gets me back to negative 16? So now that I've factored out this 2, now I have this nice, pretty quadratic that's going to be much easier to factor. And so I'm going to do that over here. And then what 2 numbers multiply to negative 24 but add to 10? Let me think about that. Oh, the answer was right there to begin with. So 8 and 3 will do it. So let's see, 8. Oh no, that's not going to work. So what 2 numbers multiply to 24 but add to 10? I originally thought 8 and 3, I know, multiply to 24. But no matter how I play with the negatives, I'm not going to quite get to 10. So that's not right. I could also recreate like all the multiples, figure out what all the multiples are, and then do combinations of those. But I think I see it with 12 and 2. So 12 and 12 gets me to 24. And then 12 is only 2 away from 10. So I want 10 to be positive. So I'm going to make the smaller number negative. So just double check. Negative times, or sorry, positive times a negative gets me negative. 12 times 2 is 24. Good. And then 12 minus 2 is 10. Great. So I'm going to come over here, and I'm just focusing inside this, this box here. I'm going to bring that 2 down for the ride in a second. So x plus 12. And then x minus 2. And then I'm going to overshoot and see what I can pull out. So here, I can definitely pull out a 3 out of both of those. So I'm going to factor out this 3. And then here, I can't pull anything out. And so then that 3 was just extra. I'm just going to get rid of it, erase it, whatever. And then there was this 2 up front. That 2 is still there. It's still 2 times all this stuff. And so this is going to be my answer, obviously, without the scribble mark. Just to come back real quick up here, these not only each have a 2 in common, but they just happen to have that y. So if I want to pull out the greatest common factor between each of these terms, I'm going to pull out a 2 and a y. And then I'm going to get the same thing that we got over here, or at least I had better once I go through this. And so then in this case, this would be my greatest common factor, and then that would be the thing that was multiplied in front. So this thing factored would be the 2y. There we go. So I hope that helps. Level 1, level 2, and level 3 factoring. You do have a level 3 on your quiz, so that's why I wanted to make this video for you.